Assalamualaikum and selamat sejahtera. This is Group 12 video presentation, Energy Management and Efficiency in UUM Campus. This is the full team member of Group 12, Muhammad Firas Aliam bin Zainuddin, Muhammad Amirul Danish bin Nur Hisham, and Nick Irene Natasha binti Nick Razlan. I'm going to talk about energy management today. What exactly is energy management? Energy management is the process of tracking and optimizing energy consumption in order to reduce energy consumption in a building. Why energy management is important? There are currently compelling reasons to do so. First, reduce greenhouse. We must reduce the amount of greenhouse gases in the atmosphere, such as carbon dioxide. The use of fossil fuels and the removal of trees, which naturally remove carbon dioxide from the atmosphere, has resulted in an increase in greenhouse gas levels. Second, reduces risk of energy scarcity. Energy scarcity refers to a shortfall or interruption in the supply of energy. Oil scarcity has triggered an energy crisis. Third, maintain energy prices. Energy efficiency can prevent you from the financial consequences of high energy prices. And the last one, which is the fourth, save costs. Saving money by lowering your energy consumption. For example, using more energy efficient LED lights can lower energy consumption. I'm going to explain on how to start energy management and efficiency in campus. There are 8 precise steps. Step 1 is using energy management pyramid. The energy management pyramid is a method of categorizing energy options. It is prioritized in order to aid progress toward a more sustainable energy system. We can focus on saving energy in each tier, from tier 1 to tier 3 by using this pyramid. Step 2 is using energy management metrics. We must assess our energy management using an energy management matrix. The energy management matrix is a model that contains the essence of levels as well as organizational action steps at each level. Each level has its own set of standards to meet as a guideline for what it should be as the management system evolves. Each column focuses on one of 6 critical aspects of energy management: energy policy, organizing, training, performance measurement, communication, and investment. The ascending rows from 0 to 4 represent the increasing complexity of these issues. Step 3 is using Energy Management Implementation Framework. The Energy Management Implementation Framework is a management system standard that assists us in approaching our action in a systematic manner. This makes it easier for campus to incorporate energy management into their overall quality and environmental management efforts. We can, for example, use ISO 50001 as a management system standard. ISO 50001 established a framework of requirement for campus to create a policy for more efficient energy use and utilize data for better decision making. Step 4 is energy policy. Energy policy that complies with all energy-related procedures, standards, and laws. We can raise energy management awareness among university staff and students through energy policy, produce professional personnel with relevant expertise in sustainable energy management, and prioritize the aspect of sustainable energy in the university green procurement. Step 5 is working group. A working group is required for energy management. It is impossible to manage everything without a working group. A working group is a group of people who have been chosen for their expertise or experience to work together to achieve a specific goal. A working group can be made up of people from various roles, division, or organization. Step 6 is energy audit. An energy audit is a survey and analysis of energy flows for the purpose of energy conservation in a building. So here's how to make the most of an energy audit. Step 1. Benchmarking. The first step toward true energy efficiency is benchmarking. It compares a building's energy performance to that of other similar buildings. It then provides a clear understanding of which building should be prioritized. Step 2 is plan. Develop a plan that prioritizes which facility can have the greatest impact and audits them first. Step 3 is audit. The audit will make specific recommendations on how to reduce energy consumption. Step 4. Implement. In order to see results, energy conservation measures must be implemented. Utilize the earlier created plan to determine which larger, more capital-intensive projects make the most sense to implement. Step 5. Measure. After completing energy conservation measures, results should be measured and the facility should be reassessed to confirm the expected energy saving. Step 7. Setting target and plan. Step 7 is to set goals and plan based on the energy management pyramid. Tier 1 refers to energy consumption, which is largely determined by behavioral and operational practices. The highest return on investment. There is no cost to carry out this plan. For example, we can save energy by simply turning off the light when not in use. Tier 2 is concerned with conserving energy and purchasing and installing energy efficient equipment and processes. In this case, we can use an LED bulb to reduce energy consumption. Tier 3 is made up of renewable energy. Less renewable energy is required when the system is modified to use efficiency. In Tier 3, we can use solar PV to renew energy by utilizing the heat from the sun. The last step is performance review. We need to review performance of energy management using PDCA. PDCA is a method for improving processes and product continuously. PDCA refers to plan, do, check, and action.
As a result, we will concentrate on three issues: global problems induced by climate change, national concern focused on energy security, and our personal problems, both environmental and economic. First and foremost, we must understand what climate change is. Long-term changes in temperature and weather patterns are referred to as climate change. These movements could be caused by natural causes such as oscillations in the solar cycle. However, human activities have been the primary cause of climate change, owing mostly to the use of fossil fuels such as coal, oil, and gas. Climate change is caused by global warming. So, I break it down into three parts. The first is an explanation of what global warming is. The second is an explanation of the global warming effect. And the third is an explanation of the steps we must take to solve this problem. What is global warming? The term global warming refers to the process by which the earth heats up and the temperature rises. It occurs when greenhouse gases like carbon dioxide, vapor, nitrous oxide, and methane trap heat and light from the sun in the Earth's atmosphere, causing the temperature to rise. Many people, animals, and plants will be harmed as a result of this situation. Many people are unable to cope with the change, and as a result, they die. Global warming has a wide range of consequences. We identify five repercussions here: flooding, sea level rise, unstable weather, rise in temperature, and loss of natural habitat. The first effect of global warming is flooding. When the atmosphere warms due to climate change, it can retain 7% extra water vapor for every degree Celsius increase in temperature. When this rapidly cooling air condenses, the water vapor condenses into droplets which combine to make a heavy rain. Flash floods can be caused by heavy rains in a short period of time, or moderate precipitation over a few days might flood rivers or dams. Secondly, sea level rise. One of the most noticeable implications of global warming is that sea levels are rising quicker. If sea levels continue to rise at this rate, numerous coastal countries such as Fiji, Singapore, Bangladesh, Egypt, and others will swiftly sink. Following that, once countries are submerged, there will be widespread harm to the species that lives in these countries. Furthermore, the number of casualties could not be determined. Third is because of unstable weather. One of the main implications of global warming that might disrupt food supply chains and community systems is natural weather variance that affects seasonal dates. such as yearly flowering plants or unexpected changes in agricultural yields. Furthermore, global warming causes differences in the volume and pattern of rainfall, which can lead soil to become wetter or drier depending on geography. Next is rise in temperature. When high temperatures combine with other weather conditions to create an excessive heat event or EHE, the risk to public health is greatest. Temperatures such as dew point temperature, cloud cover, wind speed, and surface atmospheric pressure all contribute to EHE days, which are dangerous enough that can cause heat-related deaths. The last one is loss of natural habitat. Besides humans, animals also have been affected. When land and sea change rapidly, the animals that live there will inevitably perish if they do not adapt quickly. Some will succeed, while others will fail. Many terrestrial, freshwater, and oceanic species are shifting their geographic ranges to cooler climates or higher altitudes to avoid warming. There are four things we can take to address the global warming issue. The first step is to change the light bulb. Compact fluorescent lamps (CFLs) outperform standard light bulbs. CFL bulbs last 10 times longer than incandescent lights and consume two-thirds the amount of energy. If they don't like the light bulbs, they may take them out and replace them in places like closets, garage, and storage facilities. Second, reduce your use of heat and air conditioning. The main refrigerant used in air conditioning units is hydrofluorocarbon HFC organic compound content. HFC is a much more potent greenhouse gas than carbon dioxide. The use of air conditioning units, on the other hand, necessitates the use of electricity, which is generated using fossil fuels. Therefore, they can put in weather stripping and party around doors and windows. Third, make the transition to more environmentally friendly modes of transportation. Transportation sustainability is primarily determined by the efficacy and efficiency of the transportation system, as well as the system's environmental and climatic effects. Transportation emits more greenhouse gases than any other energy consuming business. Lastly, renewable sources of energy. Growing renewable energy contributes to the creation of jobs, the resilience of electrical systems, the expansion of energy access in developing nations, and the reduction of energy bills. Humans have relied significantly on coal, oil, and other fossil fuels to power everything from light bulbs to automobiles to factories. Because fossil fuels are ingrained in practically everything we do, the greenhouse gases emitted by burning those fuels have reached historically high levels.
Energy efficiency may be described as utilizing the same or less energy to generate the same or better result, or using less energy to do the same work or enjoy the same degree of comfort. It also minimal use of energy without compromising comfort, safety, and quality. These are the hierarchy of energy management. Bottom one is energy conservation, that are behavioral change in culture or habit, such as we must turn in off lights when you don't need them and unplug your battery charger. The middle one is energy efficiency. For renewing process, for example, use the motion sensor LED, use heat gain in our building, and also use the energy star appliance like refrigerator, air conditioner, and others. The top one is the renewable energy that using the alternatives such as the solar energy, wind energy, and biomass from plants. These are the renewable energy such as biogas, geothermal, small hydro, solar PV, and biomass. First, biomass is organic matter that comes from recently living plants and organisms. Using wood in your fireplace is an example of biomass that most people are familiar with. Second, biogas is a renewable fuel produced by the breakdown of organic matter such as food scraps and animal waste. It can be used in a variety of ways, including as vehicle fuel and for heating and electricity generation. Third, solar technology converts sunlight into electrical energy either through photovoltaic panel or through mirrors that concentrate solar radiation. This energy can be used to generate electricity or be stored in batteries or thermal storage. Fourth, small hydro is the development of hydroelectric power on a scale serving a small community or industrial plant. In hydroelectric power plants, the potential energy of water due to its high location is converted into electrical energy. Lastly, geothermal energy is the heat that comes from the subsurface of the earth. It is contained in the rock and fluids beneath the earth crust and can be found as far down to the earth hot molten rock magma. These are the simplified circle of energy management process. First is organize management resource. Second, appoint an energy manager. Third is the prepare an energy policy. Fourth is a set up an energy monitoring and reporting system. Fifth, implement staff awareness and training program. Sixth, conduct energy audit. Seventh, prepare action plan based on energy audit findings. Eighth, implement action. Ninth, report and review result regularly. Lastly, annual review. Another alternative way to use energy efficiently for Universiti Utara Malaysia is a basic green building that focus on sustainable energy like low carbon building, starting with basic energy efficient future. Low carbon building is similar to conventional green buildings system, which promotes use of green technology and green habits to reduce the degradation of the environment. The low carbon building use carbon as metric for quantitative reference to assess the actual environment and not based on points collected. Go for low carbon building option if cannot afford to go green buildings. These are the example of energy efficient building. The first one is Green Energy Office Building, Pusat Tenaga Malaysia at Bangi. The second one is Low Energy Office Building, Teknologi Hijau and I, Putrajaya. The third one is Diamond Building Suruhanjaya, Tenaga at Putrajaya. In conclusion, sustainable energy management is more conveniently conducted in practice by using tools and techniques that arrange and observe the process. It is essentially complex as a sum of operations that are to be performed at certain time and in a specific way. It is to ensure efficient use of energy in the organization.